Welcome to the Linke lab, where we perform quantum computing on trapped ions. The sort of cartoon of our lab is shown right here. We perform quantum computing, which is very similar to classical computing, except it's performed on these things called quantum bits, which ultimately store and manipulate information. However, quantum computing is a little bit different from classical computing because the ideas of entanglement and superposition allow you to perform a large amount of parallel processing, so you can do single operations to get a large number of answers at once. We perform quantum computing in particular on a trapped ion system, which are shown here. They're basically individual atoms that we shine these laser pulses on to control and change the information. So now we're going to show you how we actually do this in the lab.
So how do we start an ion? We use blade traps with electric field to keep them confined. So this is the picture of the blade trap, and this is different segment. And we put the electric field on this side and the electric field on the opposite blade, and the ion is confined here. This is how it looks like in a vacuum chamber. We will show you next in the experiment table how the trap looks like.
Now let's take a look at what a quantum computer looks like. This is our computer on this optical table, and here is our trap in this vacuum chamber. This is where we have our qubits, which are ions. And so this looks very different from your laptop or desktop, but they do share some similar concepts. This trap is the chip of our quantum computer. And so instead of using circuits to operate on the chip, we use optical beams, as shown right now on this optical table. And we have lasers at different frequencies that we use to manipulate the ions. And now here, let's take a look at this live image of the ions in the trap. Over there, we have 5 ions, and we are also able to move the ions around in the trap by changing the voltages of the trap. See, we're moving it left and right. Okay, then we're going to take a closer look at one of the lasers we use to cool and manipulate the ions.
As Inge said, this is the coolest part of our experiment. Here we are using different frequencies that we can associate to different colors. In particular, here we have the red light, and we input this red light through this Doppler cavity, and at the end we recover a purple light.
Thanks for visiting the Linke lab.